Hey 99ers, welcome back to the latest episode in my series on BASIC for the TI-99. Today, I want to show you a few of my favorite tricks for writing fast, great-looking extended BASIC games, and programs in general. Tricks that show off what the platform can do, and let XB programs do a few things that, well, you'd maybe figure extended BASIC can't do at all. This is a bit of a change, since I've spent a lot of time lately looking at assembly support routines that let you do things that, a lot more straightforwardly, you really can't do in pure XB. I looked at the missing link and the way it gave us bitmap mode in TI-99 BASIC, and I looked at XB Gem and the access it gives you to even more display options and video modes. And I looked at the XB Game Developers package and the cool stuff you can do with that. But now I'm going back to the tools Extended BASIC gave us in 1981 to see if we can't optimize the crap out of them. Because as great as it is to be able to compile your BASIC these days, I honestly think you don't need to make a good TI-99 BASIC game. Folks managed to do some pretty great things in plain interpreted XB back in the day. And even in the much slower BASIC built into ROM, we got our share of playable games. So we need to take a look at how you can get those results in your own programs, or how you can do even better in some cases, including a look at how you can make your BASIC backgrounds look great, and how you can work with TI-99 sprites to get all the detail and animation you want. But first off, we need to take a look at a couple things extended BASIC coders can do to get the performance we need. Because XB does let you do some pretty impressive stuff with TI graphics. The main trick is often just figuring out how to make it happen fast enough. One thing you can pretty much always do is get your XB program starting faster. And you can do that by disabling pre-scan, the phase of execution when XB goes through your program, finding variables and subprogram names. Even for a simple mid-sized program like Sam Moore Jr.'s Doggone Boogie here, from enterpress to execution is about 5 seconds. So I'd like to get rid of that. A music program like this makes a pretty great case for ditching pre-scan because, while it's fairly long, it's really just the same thing over and over. Call sound commands, all the way down. So it's kind of a pointless waste of time to have BASIC scanning through the program searching for new subroutines and variables. It's just going to be more call sounds. So to get around this, I'll put a magic line at 275 just after the program's declared its variables. And that magic line is going to be go to 280, call sound, exclamation at P-, which in reverse order is a magic exclamation at P- token to turn off pre-scan, preceded by the name of the call sound subprogram, so that's found by the pre-scan before I turn it off, and before that, a go-to ensure none of that magic nonsense actually gets executed. Run the program now, and it starts instantly. Why worry about a few seconds lost at program start? Well, pre-scan can get a lot longer than that. And in multi-file programs that pass control back and forth between more than one file, it's not necessarily just a one-time thing, and could be a constant occurrence. A program like Legends 2 would have way more egregious load times if every time it passed control to a new file, it had a pre-scan of the whole darn thing. But by disabling pre-scan, it avoids all that, and it goes straight to executing code. But I don't just want my programs starting fast, I also want them running fast. And there are certainly a few performance pitfalls to avoid there. One of the more insidious ones being the RND function, which is where you get your random numbers in extended BASIC. The thing is, RND is crazily slow, so you really just shouldn't ever use it anywhere that performance matters. Because there's a better, faster way to get your random numbers in XB. See, the other half of the XB random number generator is the randomize function. And that's going to put a 16-bit pseudo-random value in scratchpad RAM. So if you just peek it like this, you get two random numbers several times faster than you'd get a single random number from R&D. But if you're most people, basic math functions probably aren't the thing that get you most excited about coding on a TI-99. Probably XP's graphics are a bigger deal for most of us. So let's take a look at a few things you can do to make them look their best. In the standard video mode you'll see in XP, any tile on screen is an 8x8 graphic that uses 2 of a possible 15 colors. And in some games, like RPGs, designing your tile set as a tile set can make sense and look great. Which is to say, with 8x8 water tiles that look like water, and forest tiles that look like forest, and all that sort of thing. But I'd just like to point out, you can get a lot out of this graphics mode by doing exactly the opposite of that. And instead of designing your graphics in 8x8 chunks, placing them across tile boundaries for extra color. You can see in this demo from a recent video, all the characters are spread across multiple tiles, so they can have a two-tone effect. And even the plants in the picture spread one pixel row below their main tiles to add a bit of dark red earth at the bottom. The point here being, tile boundaries were meant to be violated, since when you cross that tile boundary, you've got a new opportunity to add color to the picture. Even if it's just a second color similar to the first one for a two-tone effect. Like that cyan-blue contrast, which is one of the best color combos on the system. And you really do have some great tools in this department, given the TI-99 palette has some really good gradients. It has 3 reds, 3 greens, and 3 blues, if you count cyan. I think my favorite game for showing off those gradients is Arcturus, where the game uses each of those gradients for its level palettes to give a sense of light and shadow. And while Arcturus very much isn't an extended basic game, there's no reason you can't use the TI-99 palette just as effectively in XP. There's no speed limit on color, though speed is definitely a concern in just about every other respect when it comes to TI-99 graphics. Getting graphics on screen quick enough, looking the way you want, is the name of the game. So let's talk about tools in that department. It seems to me it makes sense to talk about our options here, starting with the ones that put graphics on screen fastest of all. And the fastest of all in Extended Basic is Call Clear. Absolutely nothing puts tiles on screen faster than it. All 768 screen locations are reset to character 32 in under 10 milliseconds. As fast as just about anything ever happens in XP. And while in keeping with the name, the idea is to clear the screen with a blank character, Character 32 can, in practice, be any pattern or color you like. So, Call Clear can set up a background, even when you do want something there. Like if I want my game here to switch out instantly to this Game Over screen, Call Clear is a perfectly sensible way to do it. As long as in this case I set Character 32 to the red brick pattern I want. After Call Clear, the next fastest way to put an image on screen in XP is Call Color, which is supposed to be for assigning foreground and background colors to tiles, but is also a rather sneaky and rather speedy way to display graphics, by changing their colors to visible ones. So take this animation for example. Since I was starting on a black background, Call Color was an easy way to show the image over time, exactly the way I wanted. Initially, all tiles are black on black, and I give them a foreground color at whatever timing suits me to reveal the pattern that was always there. Call Color could work a lot faster than that, since your palette data for the whole screen in XP is just 14 bytes. But in this case, the whole image popping in at once would kind of ruin the whole effect. So I had to slow it down. And that kind of delights me. Because anytime XP is faster than it needs to be, well, I like to revel in that. One place you'll see this strategy used in actual gameplay is the simple basic game Road Race, which does absolutely all its animation with Call Color. Everything being displayed is just something already on the screen, having its foreground color switched out to make it visible. So that's a pretty cool strategy, even if most of the time you're probably going to want a more straightforward approach to putting graphics on screen, like display at, which is your main command for writing strings to screen, and which can display a string anywhere in the inner 24 by 28 screen area. In the basic built into TI-99 ROM, print really is your best tool for writing a full screen of characters. But in XB, display at is a lot faster than print, since it doesn't need to scroll the screen every time it prints a line of characters. It will wrap to the next line though, which ends up being pretty handy. As a consequence, one display at can print the whole printable screen area, and do it way quicker than multiple calls ever could. So my suggestion is, if you're printing more than one line, absolutely do feed them to display at all at once. Alright, so 8x8 tiles with 2 colors apiece are your main graphics on the TI-99. And getting them on screen quickly is job number 1. But in XB, background tiles do pretty often kind of take a back seat, both literally and figuratively, to our other main graphical asset, sprites. It's pretty hard to overstate just how useful and powerful sprites can be in XB. The TI-99 gives you one background layer and 32 sprite layers. So if you're not using sprites, you're only seeing 3% of the landscape. And you won't be able to use motion and color nearly as freely. Take this dungeon scene, for example. I'd like to add red flames to those sconces on the walls. But I'd rather not get rid of the wall pattern to do it, and I've already used 2 colors there. So I take advantage of those sprite layers and make the flames static sprites. Just because sprites can move doesn't mean they have to. But on the other hand, why not animate them? They are sprites after all. And while animating them, I can have their color oscillate between yellow and red too for added effect. Since XB's sprite command lets me do all of those things. Set pattern, color, position, and even motion if I want it. Faster, more flexible animation really is a big benefit you get from sprites. Since the call pattern command only has 1 byte to worry about when it updates a pattern for a 16x16 sprite, where call char has 32 bytes of pattern to worry about in a 16x16 pattern area. Now to give call char its due, you can do animations by changing tile patterns on the fly with call char. And you can see that a 1-tile circular scroll is even possible here, by rotating through 8 variations on the tile that makes up the water surface there. But that was animating a 32-tile wide row, so with 4 sprites per scan line, you can't do that kind of thing with sprites regardless on the TI-99, because that sprite limit is something every XP sprite program has to navigate around. In my dungeon scene there, I dodged that bullet by having the torches sit above and below the playfield, so there's no need to worry about competing with the player sprites. They're just going to keep to their own scan lines there. So you might figure horizontally consecutive sprites on an active playfield are kind of a no-no. But there are a few games that use horizontally scrolling sprites really well in XB. One example of that I really enjoy is the game Spring-Heeled Jack, where the holes you need to jump through on each tier of each level are all sprites. And the game uses sprite collisions to tell whether you managed a safe jump. There's really no better way to work that much background scrolling into a pure XB game. So, while this is the solution we're stuck with, it's also thankfully one that works pretty well. So just for example, you can maybe imagine this sort of background as the basis for an endless runner or that sort of thing, with absolutely everything that's moving here being a sprite. And granted, 4 per scan line isn't a lot to work with, but making them double-size magnified sprites maybe helps fill things out. And sprite magnification is surely a feature worth talking about here, since by default your TI-99 sprites are only 8x8. But you can get yourself 16x16 or even 32x32 sprites by calling the call magnify command. Most extended basic sprite games do use sprite magnification, so you'll see sprites that are double-sized and magnified a whole lot if you poke around the library. And one reason double-size magnified sprites are so popular is just that the smaller your sprites are, the harder your collision detection is going to be to get right. And getting your collision detection right in XB is a high priority. So you're making it easier on yourself in the collision detection department, making your sprites huge. Since more sprite means more collision to work with. But in the long run, the best way to make TI-99 sprites look great isn't making them huge. It's layering them. Because while each TI-99 sprite's only one color, there's nothing stopping you from stacking up to 4 of them for more color and detail. Even in plain old extended basic, we can stack a few sprites to make Mario swim, and have him stand out in 3 colors instead of 1. And the call sprite command is actually fast enough to handle a 4-frame animation involving 3 sprites in motion. And it'll be easier to see what goes into making up Mario here if we spread him out a bit, so we can see how it all comes together. And now you can clearly see the 3 sprites that make him up, with the call sprite command changing the pattern and position for all 3. A character like that maybe isn't the best way to show off TI sprites though, just because of where limits are. I've put all my sprites on one scan line in 2 different demos so far. So let's correct that and get some mileage out of the fact that as long as you spread your sprites out vertically instead of horizontally, there's no limit to worry about, and you can make some bigger graphics with TI sprites. If I make a character that's built out of multiple sprite groups, one over top of the other, I've still got at most 3 on a scan line, like Mario had, but I can make my character however tall I want. You can see what goes into this, and you can see all the sprites that make up the character if we spread them out, just like we did Mario, with 3 sprites on top and 2 on the bottom. And I'll admit our animation got a bit flickery there, handling animation for 5 sprites and sound effects all at once. So, let's look at how those animations perform if we compile the program with the XB Game Developers package. A lot smoother as you'd expect. There is, I'll admit, a lot more time to position and animate large sprite groups once you've compiled, and those sprite commands are even faster. Something you might notice about that animation is it's not using Automotion, where the machine moves the sprites in a direction you set at a rate you set. Instead, the character is just being repositioned and given a new pattern every animation frame. So, why not Automotion? There are upsides and downsides to ditching Automotion. On the upside, where your sprites are is never a mystery. Your basic program knows where they are, since that's where it put them. But on the other hand, in some games, clearly, sprites automatically moving in some direction is most of what you want them to do. And figuring out where they are, when, and if a collision happens, is gonna work just fine. Plus, there's even a hidden value in having something in XB that moves on an automatic timer, since that indirectly gives XB a solution for measuring periods of time. In this scene here, for example, I've set things up so that my little boat moves at speed 2, which means that Sprite Automotion moves at 1 pixel per 8 VDP interrupts. The upshot being, my program can measure how many seconds have passed, accurately, at any time, by checking what pixel it's on. And my little boat's gonna pass the 30-second mark at exactly 30 seconds. If you need a timer in XB, with Sprite Automotion, you got one, even without a real-time clock. And sprites can be positioned well off the bottom of the screen, so there's plenty of space for it. Though on the other hand, if you want to implement timers in your programs by having weird boats floating various places instead, that's cool too. Fun fact, sprites aren't deleted when your program passes control to a new file with the run command. So, effectively, using sprites as variables when bouncing between files is a viable, if ridiculous, strategy. Say you're writing the next great TI RPG and you want to keep your character stats persistent when bouncing from file to file the way games like Old Dark Caves and Legends do. Well, you could store them as sprite positions or even character patterns. Is that kind of silly? Well, yeah. But on the TI-99, nearly all our RAM is VDP RAM and we can't poke data into it. So, misusing data types you can access sometimes makes sense. But most of your sprites probably aren't going to be variables. And most probably aren't going to be background graphics either. They're probably going to be projectiles and player characters and enemies and whatnot. And when it comes to that kind of sprite, grabbing positions and managing motion and checking for collisions and all that business is one of the biggest optimization challenges on the TI-99. When two sprites overlap, like when your ship and an asteroid collide in an asteroids game, you'd usually want your program to notice that and respond however it should. And it just so happens the TI-VDP has a status register with a bit whose job it is to flag a sprite collision. So XB has a fast, accurate way to check for that. Call coinc all can check for a sprite collision in under 15 milliseconds. So, performance-wise, if that's part of your main game loop, you'll barely notice the performance hit. The downside is this doesn't tell you what sprite collided, or where. And in most games, checking for every possibility is going to be too slow. So you really have to make your collision logic work for a system where detecting a collision is easy, but detecting where it happened is hard. Happily, there are some good strategies. The simplest solution here is kind of obvious, a design with only one kind of collision. So a fast check with call coinc all tells you everything you need to know. Roland Truman's Crazy Cliff the Climber is one of these, and it really does manage responsive control and good animation thanks to that simple collision detection logic. That being, if there's a sprite collision, Cliff's been hit, and he should fall. Truman's Flip Flap is another game like this, with player-enemy collisions being the only kind. But on the other hand, you can get away with a little more complexity by having two, and only two, types of collision. Jimbeck's Shuttle does that. You want to hit the target probe, and you want to avoid the asteroids. So the game needs to know which of those happened. But with only two types of collision, the program just needs to ask, is there a collision between the probe and the ship? And if true, you hit the probe and score, and if false, you hit the asteroids and die. And performance is still fine and detection is accurate. My favorite solution though for detecting collisions in XB is a pretty weird one. See, the VDP status register doesn't tell you which sprites are colliding, but when a fifth sprite exceeds the 4 sprite per scan line limit, it does tell you exactly what sprite exceeds that. And the upshot is, if you put 4 high-priority sprites on a scan line, even invisible ones like I use here, the VDP will tell you exactly what sprite entered those scan lines every time via the status register. And you can grab that sprite number with a peek, like this. There is no faster way to track collisions for a large number of Automotion sprites. Though, this strategy would only be useful for certain kinds of game, like a breakout-style game, for example. Anyway, enough sprite talk for now, because it's time to talk about TI sound, and what it can do for an XB program and what you can do to make it more interesting. Now, as I've said before, your main limitation generating sound on the TI-99 is that your tone generators are generating square waves, and those can be a little harsh and a little bland. So, queuing up this TI Basic Star Wars theme I dug up. Well, there's just not much to it. But I have a few suggestions on things you can do to make basic music more listenable. So, I'm going to feed all those Star Wars themed pitch values to a subroutine I've written that does some music math for me in an attempt to interestingify this song. Instead of playing just one pitch on one tone generator, it'll play the original pitch and 2 more besides, 1 hertz above and 1 hertz below. And that sounds like this. But another thing I'm doing there is giving the note a falling contour, and that really helps the sound more natural. Because most instruments don't play sound at fixed volume with no attack, decay, or release. So, playing our TI Star Wars tunes together, the contrast is pretty stark. The upshot being, you can do a lot to make basic music more interesting. And while that Star Wars tune used 3 clustered voices to give the sound more texture, you can use 2 voices and get the same effect, saving 1 for any other notes you need to hit along the way. So for an example of that, here's some TI Basic Bach, with 2 voices carrying the main tune, but the 3rd generator freed up for other notes. But just to cause trouble, let's say you've got a song where you absolutely need to play all 3 notes in a series of chords, so no spare tone generators to be had at any time. Even then, you can get more out of your TI music by giving the sound some kind of volume envelope. So here's a bit more Bach doing that. And finally, even beyond the TI-99's 3 main voices, you do have one more sound option available, and that is, of course, noise generation, which you can even carry a tune with, like Sam Moore Jr. did here. The bad news is, if you want to tune your noise on a note-by-note basis, it needs to borrow its pitch from Tone Generator 3. So it's not really giving you one more voice there per se. It's giving you what's more like a new instrument, with its own range and sound. Alright, well, thanks for joining me, folks. For a bunch of basic coding tricks I happen to find fun on the TI-99. The fact is, I don't think I'd find Extended Basic anywhere near as fun as I do if squeezing every last bit of performance out of it weren't such an interesting challenge. So, I hope that makes sense to some of the rest of you maniacs. If you'd like to join me on my TI-99 travels in the future, hit subscribe. And catch me next time. This is Pixelpedant signing off.